In this section, we are going to make various definitions. Let's start with data science. Wikipedia defined the term as multidisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data. Data science uses many different fields. For example, if you take a look at this graph on the right-hand side, you will see that data science projects can use mathematics, statistical research, domain expertise, data processing, computer science, and also machine learning. What is machine learning? We are going to use some definitions from Arthur Samuel, who was also a pioneer in the AI research. He also coined the term machine learning in 1959, quite a while ago. He said that programming computers to learn from experience should eventually eliminate the need for much of this detailed programming effort. So what he is saying is that we can actually teach computers to do some tasks. Let's compare this classical programming and the machine learning approach. In the classical programming case, we usually need to construct some handwritten rules. We can, for example, use the programming if and else statements in this case. And by using these rules, we can get to some answers for some questions or for some problems. In the machine learning case, we are going to do things differently. We are going to get a problem. This can be the same problem as we were trying to solve with classical programming. But we are also going to provide the answers beforehand. And we are going to use some machine learning algorithms. And these algorithms are going to learn the rules through training. Once we train this model, this time the model can do the answers or can do the task for us. Let's talk about machine learning lifecycle. As always, a machine learning lifecycle starts with a business problem. This is the problem that we are trying to solve. We formulate this problem, and after that, we come to the data processing stage. Here, we are going to do some processing on our data. It can involve data collection, data pre-processing, visualization, augmentation, and feature engineering, and more. And after that, we get our machine learning model, and we train, tune, and evaluate the model. After the evaluation, if the model meets our business goal, we can go ahead and deploy it. If it doesn't, we need to go back and check our processes. After the deployment case, if we have some more new data, in this case, we can go back and retrain the model. Let's talk about some important machine learning terms. We are going to use some analogy from statistics and mathematics here as well. And we are going to go one by one. Let's start with the first one. Label, target, or why. This is simply the thing that we are trying to predict in machine learning problems. In statistics, we can also call this dependent response or output variable. Those are all going to mean the same thing in our case. Feature, or X. This is the data that help you to make some predictions. We can also assume that this is the data that we use to train a machine learning model as well. This can be independent, explanatory, or input variable. Feature engineering are some type of tasks that we do to reshape our data to get more value out of it. These can be some type of transformations. Dimensionality can be the number of features that we use. For example, we can see some things such as 1D, 2D, or all the way to ND in our machine learning problems. These refer to how many features that we have. Model weights, or parameters in the statistics case, are the set of parameters that are embedded in a model that we use to make some predictions.